The last section of probability that we're going to cover is probably the most fun because you get to do some real troubleshooting and problem solving here, and it's always great when your answers come together and the math starts to work in the way that it was designed to. So this section is called Venn diagrams, and before we dive into any examples, let's just make sure that we understand each other. So we need to know what the terminology is in this case. So a Venn diagram is always going to be represented by a rectangular sample space, and then inside of that sample space you will have one or more sets. Okay, anything that is outside of that set is then obviously not in the set. That might seem obvious, but it's important to state these things. And when it comes to writing down or labeling these diagrams, we don't usually write things like sample space and set. That's how we talk. But when we write down our labels, we'll often say NS, and we'll even say how many elements are in this sample space. So let's pretend we interviewed 100 people. Then that would generally go outside of our sample space. And then the sets inside are often just given labels. So for example, I said who in my maths class likes algebra, and so I'm going to call this the set A for algebra. And so any learners who put their hand up to say I like algebra, they're going to go inside of this set, and any learners who don't like algebra, they're going to go outside of this set. Now when it comes to working with probability specifically, then this word events should be something that's quite familiar to us now. An event is basically the favorable outcome that we are looking for. Okay, and there are different ways that it can be tested in a probability Venn diagram question. Okay, and I've split it up into the two main headings here. Either the events are inclusive or the events are mutually exclusive. And straight away, you can spot a very clear difference. Okay, inclusive events means that they can overlap, and mutually exclusive events means that they happen without interacting with one another at all. So event A and event B are mutually exclusive because they don't overlap. All right. Now, when it comes to overlapping, there are two important words that we need to know. The one is this word here, intersection, and the other one is this word here, union. So once again, let's just talk about events A and B, and let's call these events C and D. If they asked me for the intersection, which we in terminology speak will use the word and. Okay, so if ever your probability question says something about and, then they are asking for the intersection, and the intersection is just this portion where A and B are both present. So very important, that is and sometimes the question will even use the intersection notation, which looks like an upside down U. So there it is, and. That's not always common, but it is helpful to just know all the different options in case it does come your way. Then we get the union, and the union, the terminology they use for the union is or. So intersection is and, union is or. And if I say to you, all right, it needs to belong to either C or D, then that means it can belong to C, it can belong to D, or it can belong to C and D. So this union is a much bigger spread of the data, or at least of the elements, and so there's probably a higher probability than finding something in the intersection. There's also a symbol for union, and that's the symbol that looks like an upright U, and that kind of makes sense. U for union, that works out well. I usually remember that the N in and looks a bit like this upside down U that we use for intersection, and the U in union reminds me of this upright U that we use there as the symbol. Okay, something worth noting here, if I asked you for the intersection of mutually exclusive events, can you see that at no point do they overlap? So for these mutually exclusive events, finding the probability of A and B, okay, that's the intersection, that's just going to be equal to 0. It's absolutely impossible for those to intersect because they are mutually exclusive. All right. And if I wanted the union, so if I said to you, well, then what's the probability of A or B? Then that would simply be the probability of A plus the probability of B. So just like it was here, C or D, okay, and the intersection. But here there is no intersection, so just the probability of A plus the probability of B. Now let's put that terminology and our understanding to the test. It says here the diagram below shows the subject choices, geography and life science of the grade 10 learners at Probability Academy. All right, so geography and life sciences there at a made-up school. Determine the number of learners in grade 10. Okay, so what's missing here is straight away the number of elements in my sample space. They haven't written that. But I can definitely work that out because I know that 15 learners take only geography, 25 learners take geography, and, remember the intersection means and life sciences. 20 learners take only life sciences, and 35 learners don't take either of these subjects. So I can actually work that out, and I can say, if we say 15 plus 25 plus 20 plus 35, that's going to give us 40, 60, 95 learners there if we add that up. And so the number of elements in my sample space are 95. Okay. Now, what is the probability that someone takes geography? That's what that question is asking there. Probability G. Okay, so that means anyone inside of the geography circle is valid. Okay, be careful there because I see oftentimes students are confused as to whether or not to include this intersection. Okay, do these 25 people take geography? They absolutely do. They also take life sciences, but that's okay. The question is just saying, what's the probability that they take geography? So it's going to be the values in these two. How do we work out probability? It's the number of favorable outcomes. So 15 plus 25 gives us 40 out of the total number of outcomes. Okay, so 40 out of 95, and you can pop that into your calculator and simplify. Next up, they ask us, what is the probability that someone does not take life sciences? Now that means I want only the values that are not included in this L circle here, in this set. Okay, so I've got two options here. I can either work out, all right, who doesn't fit in, and this is a very simple Venn diagram. So in this case, they're going to look equally as easy, but let me show you the two methods. So I can either say, okay, well, everyone outside of the life sciences circle, so it's these, and I divide by the number of elements in the sample space. Or, if you remember from our previous video, we could say this is 1 minus the probability of actually taking life science, and then work it out from there. And either way, we will end up at the same answer. Okay, I think I'm going to do the first method because it is as straightforward. So probability of not taking life science is 15 plus 35. Okay, again, be careful here. These 25 are part of this red circle, so they do take life science. Okay, 15 plus 35 takes us up to 50 out of the 95. Type that on our calculator. 50 over 95 simplifies there to 10 over 19. And now, an interestingly worded question. What is the probability that someone could take geography or life science, but not both? So what do they want me not to include here? Not both means they are not interested in the intersection. Okay? So you've got to take geography or life science. You're not allowed to take both of them. And these people are also not valid because they don't take either of them. Okay, so it's just about reading the question and answering exactly what they want from us. So we've got 15 plus 20 learners who match those criteria. So 15 plus 20 is 35 over the 95 learners. And that we can simplify again. 35 over 95 gives us 7 over 19. Now let's see if you can do a Venn diagram from scratch. Okay, let's tackle this example together. In a group of 50 tourists, 30 have been to America. So there's one event. 40 have been to England. And 25 have been to both America and England. Draw a Venn diagram to represent this information. Okay, so how many events do I have, or how many sets inside? I've got America, and I've got England, and then I've got the overlap, remember, and is the intersection. So I'm going to draw a block, and in that block I need to have 2 circles. Okay, there is my sample space. How many elements are in this sample space? Well, that comes from the opening line. In a group of 50 tourists. So there need to be 50 people here. Okay, now I've got 2 events. I've got America and I've got England. And so I'm going to name this one America and this one England. Now I've got to do some work. 30 have been to America. So we might be tempted to say, oh, we'll just put 30 in there. 40 have been to England. But have a look what's happened to my total now. 30 plus 40 is 70. So I'm sitting with too many tourists. So that is not the right strategy. But let's keep it there just to guide us. Okay. 25 have been to both America and England. That one is a sure thing. We can put those 25 there. We know that that's the intersection. Okay. Now let's try and figure out what's gone wrong here with this 30 and 40. Okay. In my America circle, I need to have the 30 people, the 30 tourists who have traveled there. So if 25 of them are already represented, then I can't have 30 there. Then I need to have a further 5 because 25 plus 5 will give me those 30 tourists. Okay? And in a similar way, I've got 25 plus how much would give me this 40 here, and that's going to be 15. So there, that's a much more accurate representation. Okay, and now to check on my Venn diagram, let's just finish my color coding. England was this bluish color. Okay, so there is a chance that some tourists haven't been anywhere. So let's figure out if something or someone needs to be included outside of the circles but still in the sample space of the 50 tourists. Okay, so 5 plus 25 is 30, plus another 15 will take us up to 45. And we need to have 50 in our sample space, so that means 5 people need to be written somewhere outside. Okay, out of habit I write them in the bottom corner, but you could really write them anywhere in the sample space, but not inside of these circles. Okay, so that's our Venn diagram. Now it says how many tourists have never been to America or England. So there we go. In drawing a Venn diagram, we've actually been forced to answer that question. And so we know that that answer is 5 tourists. They may have toured in other places in the world, but they haven't been to America or to England. Okay, and then we're going to do these probability questions. What is the probability that they've been to at least one of these countries? Okay, so that at least one makes me think that is America or England. Why? Because in America, one country, or England, remember, is everything in this and this intersection. So that means you could go to either one America or one England or both America and England. So that's the or question. So it's all of those values there, which we know is 45 out of 50. And that's a very high probability. Both of those can divide by 5. So that gives us 9 out of 10 as a probability there. Okay. And then what is the probability that a person has been to England but not to America? So B, probability England but not America. All right, so America is out. Anyone who's been to America I'm not going to include them. No, no. Okay, and this person hasn't, or those 5 people haven't been to England either, so they don't suit my criteria. So I've got 15 people who do suit the criteria out of 50. Again, each of these can be divided by 5. So 5 goes into 15 3 times, 5 goes into 50 10 times. So there we have it. So if you practice drawing Venn diagrams and get very good at them, then you'll see answering the probability questions that follow are actually very easy. And so there are some questions that you're going to get to when you get to grade 11 and grade 12, and they're not going to prescribe to you like this one did, where it says you have to draw a Venn diagram. They're just going to ask you to solve, but get into the habit of, wherever possible, drawing, especially if you've got inclusive events like this. Draw these Venn diagrams and then answer your probability questions. It really does help with the understanding.